Hello and welcome to PMCD MATHS Teaching. I'm Paul McDonough and I'm just doing a video here on solving loci problems. Again, useful if you've not taught this before or you're a new teacher, but again, there might be something in here for more experienced teachers. You might think, oh, that could add on to it, just maybe improve what I'm doing, maybe add to what I'm doing. But have a look, see what you think. Usual, here's the rationale that I've got for the post I'm using for the teaching of this. Right, so I mean, it's quite a good thing to mention here is that if ever you have lessons where you feel like you're doing the work and they're just copying what you're doing, then you really do need to rethink, or we really need to rethink what we're doing, because it's painful for us. You know, I often feel like I get really hot and flustered in that situation as well. And the students aren't really learning, they're not working independently. So I'm not going to claim credit for coming up with this idea, because I think I came across this in my first year of teaching on an NQT inset that I did, and I still remember it and I still use this, and I've tried to sort of add it to it as I've gone along. And the resources that I've used for this, I can share them, but they're, you will have to check them and do them yourselves, because sometimes when you print out, the scale doesn't work. You might have to change some of the numbers in the questions. I'll explain why that is as we go through. Order of teaching. So this links to the video I did on constructing perpendicular and angular bisectors, and that's where I'd start with loci. Actually, I don't start with this lesson. I'd start with that just to get the students' head round two sort of beginner loci that they can work on. If you have a look at that video first, you might find that useful as a stepping stone into this. And from there, constructions or loci problems before the final loci, all of the other loci that we need to be able to do. Okay, so we're going to solving loci problems. Same sort of opening sheet that I've got here from the one that I did with perpendicular bisectors. So talking about loci, locus, loci being the plural. What is a locus? And if you've done the lesson before, we've had that definition that it's a set of points that follows a given rule. Okay, so we can talk about all of this, these the crop circles, and this little diagram down here showing the points of shapes that rotate. I mean, that's a nice little activity on its own as well. I haven't done a lesson on that actually for a long time, but very interesting way of actually seeing what happens to objects as they rotate. So that's another idea. Everybody wants to go on that and come back to me, that'd be great. Okay, so what I do is I start off with, as I said, visualization. So all I'm going to ask them to do, they're going to find this a bit hard to start off with, but I ask them to close their eyes and picture what's going on. How can you actually construct something if you can't even think what it's going to look like? And this is what I think a lot of students get stuck. They get a locus problem and they just read it and they've got no idea. They didn't even try to visualize. We try and encourage them to visualize. What might it look like? How can I use the tools that I've got to actually construct that in an accurate way? So only a few here, and I say to use one clean page. So we are using up book space, but I think it's worthwhile. So the first thing that I'll get them to close their eyes. I'm just putting these up on the board. If they get stuck, you can always prompt them with this, but this is more for me than for the students. Okay, so 20 seconds to complete your sketch. First one there. Okay, fence is put up around a tree to protect it. The fence must always be 2 meters from the tree. So get the aerial view of the tree and the fence. And now you're going to get all sorts here. So it's quite funny. You get pictures of trees. You get sometimes branches. Sometimes people putting birds on trees and all sorts. But after, so we do the first one, give them a bit of time, and then we share our answers. Now, it's quite a good thing to do on mini whiteboards because you can see what they've got all together then. I think and they can show each other. It's a nice little bit of peer assessment. They can look at each other's as they're going through and say, oh, no, no, it should be like this. So keywords to come out of this, because I said we're going to use these to prompt us later on. So we can say here, all of the points on the fence must be equidistant from the tree. Equidistant from the tree. And that's implied by the 2 meters from this, must always be 2 meters. So equidistant from a tree, equidistant from a point. What do we get? We get a circle. Okay, so these are little trigger things you can use later on, rather than actually saying, oh, use your compass, set it to 5 centimeters, draw this, draw that. I mean, that's not helping at all if we're doing it that way. A person along a straight road, they walk, so they're always 1 meter from the edge of the road. Okay, sketch the path of their walk. Okay, now not too hard one here, but when it comes to problems later on, you'll see that students do struggle to think what's actually going on here. But again, we can refer back to this. So we end up with a line, a set of points which are parallel to the edge of the road. Parallel to the edge of the road. Okay, so all these points are equidistant from a line. They will be parallel. I haven't drawn the picture of this, so we get into the stage now. Hopefully they know what they're doing with this. So I think about a coin. Okay, and you can imagine it. So this would say the coin rolls, it sits on the top of this line, and it rolls backwards and forwards. So just picture that, coins rolling backwards and forwards. Now picture the center of that coin, rolling backwards and forwards as well. When it gets to the end of the line, the coin rolls round underneath the line, but stays in contact with the line at all times. Okay, it does not slip. Does not slip, so every time it rolls, a new part of the coin touches the line. So just to visualize that coin rolling along the bottom of the line now, underneath, and it gets to the left-hand end of the line, and then just swings around the end of that line back onto the top. And just take that backwards and forwards. Top of the line, to the right, to the left, gets to the left end of the line, swings around underneath the line and rolls. So it's still in contact with that line along the bottom line. So now just take it doing a little circuit, going round along the bottom of the line to the right end line, round, swing around onto the top, and left and right. Okay, now visualize the center of the coin. Okay, now imagine that was a little flashing light. Okay, so you've got little dots of light there. Then keep moving that coin around that line, keep rolling it along the top of the line, around the ends, along the bottom, underneath the line, I should say, round, back round, till it gets back round to the start. What I'd like you to do now is just concentrate on the center of that coin, that flashing little dot light. Okay, and I'd like you to draw the path that light traces out. What path does the light trace out? It goes through around the top and around to the bottom. Okay, so it's practice with that. I mean, it's not perfect, but it's practice with that. Now you're going to get all sorts with that. You're going to get all sorts of this, and what we're looking for is that sort of racetrack locus. Okay, and what you'll end up with is all sorts. I'm sure you've done this before, but we're looking for this sort of racetrack where we have the curve starting at the point which is parallel to the end of the line here. So at this point here, so we end up with this curve here. Some are very good at getting it straight away, some aren't. Now again, I back this up sometimes later on. I might, a student out, get them to tie a piece of, well, not tie a piece, but have a piece of string they have to hold on to and move them around a table to show what happens when we get to a corner, that it swings around in a circle. So that's useful for some of the loci we're going to do in some problems. So that's the racetrack one. 2 lighthouses. Again, I'll give them the picture here because otherwise it's all over the place. Lighthouse 1, lighthouse 2. Okay, close your eyes. They're on a particularly treacherous stretch of sea, and because the rocks around these islands make that path very shallow. what we want to do, we want the ship to pass between the lighthouses. And the only safe path is if it stays the same distance away from lighthouse 1 as it is from lighthouse 2. Okay, so draw the path. It has to stay the same distance away from lighthouse 1 and lighthouse 2. And you will recognise this is a perpendicular bisector. This will lead into that construction. And remind them what they did when they did the perpendicular bisector. Well, look, this is practical use of a perpendicular bisector here. We're plotting that route. And again, reinforcing this locus is equidistant from 2 points. Keep using that language again and again and again until it becomes really useful for them. And the final one, which I haven't got a picture of here, is to imagine a room, a rectangular room with an electrified floor. And you've got to get from one corner, you've got to travel from one corner through this room. Okay, you're in a corner and you've got to travel through the room. And the only safe room is if you stay the same distance away from the 2 walls that your corner is. So let's just have a look here. It might have been useful to have a diagram here actually with a rectangle. So you're here, you have to walk, so you're saying the same distance away from this wall 1 and wall 2. If you don't, you're going to get a nasty shock off the floor. Okay. Now, using a rectangle rather than a square here, so that they don't think it's always going to be the diagonal. Diagonal wouldn't work with a rectangle. And if you look at this, a lot of them will. I mean, I've done this. Actually, had to act this out in the room when they don't understand, but we'd end up with the angle bisector. So that's equidistant from 2 lines, and walls are quite a good way for those students to be able to link their understanding to that. So those are the visualizations over. Once we've done those, okay, I then encourage students to say, well, yeah, you just visualize before, have a little few seconds, 30 seconds or something, and visualize what it's going to look like. Okay, so then start with a little starter problem. And you can make these up. I've got these over textbooks and my own ideas and SATS papers. I mean, that's pretty much my source of resources here. I do find that most the textbooks, they struggle to give away to do. So what you're going to do, you can't draw in a textbook. A lot of them say copy out this diagram. Well, copying's, in my view, is a waste of time. It actually wastes time, learning time in the lesson, and then you can end up getting loads of diagrams but hardly any work done. So I think it is one where you have to provide copies for students to work on to get the best out of them in that time. Okay, so I've got one here. Trying to again think about what they're doing. I mean, even this is now a bit outdated because we have cordless vacuum cleaners, don't we? But I suppose you could say that, yeah, I mean, it's a little bit more difficult, but there are still corded vacuum cleaners around. So we've got one here. And I get them to draw this out, 4 meters by 4 meters by, I can't remember what I've done this one, it might be 2 meters, I can't remember what it is now. Get them to do a rectangle and sketch where the vacuum cleaner can reach. So I'm starting to get the idea that, if it's by scale 1 centimeter equals 2 meters, by scale, we'd end up with some sort of curve centered at that socket there. The radius would be there. So sort of gets them to hang of it and saying, well, hold on, the only bit that I need here, is going to be the bit that's shaded, and there's bits that I don't need. So I'm getting in part of a circle. So I'm starting to use, it's still a locus, it's still a set of points that follows a rule, i.e. all the points which are less than 3 meters, less than or equal to 3 meters from that socket. But they're having to shade regions rather than just points now. Okay, and then there's a set of problems. Now these are from textbooks, which I've sort of adapted over the years. So question here, I'm just giving examples here. So you can make your own with these, or you can copy these ideas as you go along. So we'd say that a house is going to be built housing projects can be built so it is, I don't know, 2 miles from school and you know, more than 1 mile from the motorway. So you'd have to put all of the points which are, in other words, a line, a parallel. So again, we're referring back to that visualization. It's parallel to a straight line. Okay, so we will get a straight line, and then a circle for the school. If it's more than 2 miles from the school, you end up with something like that. So I've got my circle tool on here. So in this case, you might say, well, there's two possible places where we could build that housing development. These are just adaptations now. So, I mean, variations, I should say, of what we're doing here. So you might say it's, a cafe is going to be built so that it's 2 miles from the motorway. So we have to do all the points which are 2 miles from the motorway, and it's also going to be half a mile from the forest. And you do all the points at half a mile from a forest. Where do they intersect? The cafe must be getting built there. It's just some ideas. Then you've got a 3. It might be a certain distance from a hospital, a school, and a church. Where could it be built? And again, it might be shading a region which it can be built there as well. So those are the sort of things you can do with that, with roads, and building's quite a good one actually to use as a way of visualizing what's going on here. Okay, so sometimes these are, sometimes they're going to be regions to shade, sometimes they're going to be points that they have to actually find here. It's only 3 meters from the edge of the pond, so this sort of links back to that racetrack idea. You're going to get the arcs as the points. The fence moves around the corners of these shapes, and I threw in pond 2 as well. Something slightly different there. Okay, then I just say I do print these out, and just as a word of warning, what I also do is I also check them, because sometimes you find that your scale is not quite right and it doesn't come out as well, and you have to adjust what's going on. So it takes a while to get this to work perfectly, but once you've got it, it then becomes an interesting lesson, problem-solving lesson. Old sats question, again, you have to be careful with these, because when I screenshotted some of these to use, what happens is that the scale goes. So you really do have to check these before you just hand them out, because the scale won't be right. You can see I've changed some numbers up there, and I think that worked last time I used it, but as you can see at the top of my thing, I've put A5 to large A5 to A4. That's what I've said, and print. That's what I've done. More SATs questions, or just a variety of the same thing? Just to give a little bit of variety. These ones I like. This nearer to Ashby than seawater. And the idea that they need to be able to find the exact mid locus of all the points which are halfway between Ashby and seawater before deciding which side to shade. Just give them that practice of that wording as well. Okay. Now there are obviously lots of other questions you can get, and GCSE exams, they come up with new ones all the time, so you can always update those as well. But big idea on this one really is the visualization. So I hope you enjoy that. I hope you find something useful to use from there. And as usual, if you've got anything yourselves that you think would be useful to add on to that, then please feel free to contact me and share. Okay, great. Okay, thank you, and I will see you next time.